Let's take a look at this example. First of all, I would redraw this circuit. Maybe it is going to look a little bit simpler. So, positive terminal of my power supply I'm going to call terminal A, and negative I'm going to call terminal B. Okay, so this is my circuit, and resistor R5, R4, resistor R2 and R1 are connected to terminal A, right? So let's see how we are going to draw this circuit and make it looking a little bit simpler. So we see that negative terminal of my power supply is connected to the resistor R6, right? So I can say this is my maybe I'm not supposed to draw this line. I'm supposed to just draw resistor over here, and this is my R6, right? R6 is connected to the negative terminal of my power supply and is connected to the ground. Positive terminal, okay, this is my A terminal, this is my, by the way, B. A is connected to resistor R2 and resistor R2 is connected to the ground. One more time. Positive terminal is connected to what? To R2, right? And is connected to R2 is connected to the ground. Please notice that we have all extra connection over here. So it means that my terminal A is also connected with resistor R1, and resistor R1 is also connected to the ground. So I have resistor R1 over here, right? So let's take a look what happened next. We have resistor R5, and we have resistor R4 also connected to terminal A, right? So R5 and R4 let me just write the R4 over here and R5 over here, and they are also connected, right, to the ground. Okay, so we have terminal A connected to resistor R4 and R5, and they are again connected together over here, and they are connected to what? To the ground, right? So I can say like this, and they are connected to the ground. So what happened with resistor R3? Resistor R3 is connected to what? To terminal A, right? And resistor R3 is also connected to what? To the ground, right? So I can say that this resistor is also connected to terminal A and to the ground. This is R3, right? So one more time. We have terminal A. Terminal A is connected to resistor R2, and R2 goes to ground. Terminal A is connected to resistor R1, and R1 goes to the ground. R3 is also connected to resistor R3 is connected to terminal A because this is terminal A. okay, and other side of the resistor is connected to the ground. R4 is connected to terminal A and R5 is connected to terminal A, and both of them are connected together and are connected to the ground. So we can say that we got 5 resistors connected parallel, right? Parallel, and we have R6, which is basically in series with all of them. So what we're supposed to find? We're supposed to find I total. So in order to find I total, I'm going to find total resistance first. So because these 5 resistors are connected in parallel, I'm going to use the following formula. R total is equal 1 over 1 divided by R1 plus 1 over R2, R2 plus 1 divided by R3 plus 1 divided by R4 plus 1 divided by R5. Okay, and these are the 5 resistors plus the resistor which is in series with all of them, right? So plus R6. So I have 1 divided by open parenthesis 1 divided by R1. R1 is 4K plus 1 divided by R2, which is equal what? 4K plus 1 divided by R3, which is equal 6K plus 1 divided by 8K plus 1 divided by 8K plus R6, which is equal 3.2K. Okay, this is equal 1 divided by open parenthesis 1 divided by 4 exponent 3 plus 1 divided by 4 exponent 3 plus 1 divided by 6 exponent 3 plus 1 divided by 8 exponent 3 plus 1 divided by 8 exponent 3, close parenthesis, plus 3.2 exponent 3. My total resistance is equal 4.29 kilo ohms. Okay, so this is my total resistance. Next, I'm supposed to find the total current. Total current. I total is equal voltage source over R total. Voltage source is equal 12 volts over R total 4.29 kilo ohms. This is equal 12 divided by 4.29 exponent 3 equals 2.79 milliamps. 2.79 milliamps. This is my total current. Next, I'm supposed to find I3. Okay, I3. I3 is the current which goes through resistor R3. You're supposed to realize that all these resistors, these 5 resistors are connected in parallel, so the voltage across all of them is going to be the same, but don't be fooled, okay? This is not going to be equal voltage source because I have this resistor. So what I have to do first, I'm supposed to simply calculate the voltage across this resistor. We can simply write V6 is equal I total times R6. Of course, there are many ways to solve this problem, but I want you to practice basically different techniques. So if I total is equal 2.79 milliamps times R6, which is equal 3.2 kilo ohms. This is equal 2.79 exponent 3 negative times 3.2 exponent 3 equals 8.92 volts. 8.92 volts, okay? And this is basically the voltage which we're supposed to find, right? So this is my V6. So voltage V2 is going to be equal to voltage V3. This is going to be also equal to voltage V1 is going to be also equal to voltage V4 is also equals to V5, and this is going to be equal voltage source minus V6. Okay, so voltage source minus this voltage will give me voltage across these resistors. So voltage source is equal 12 volts minus V6, 8.92 volts. Okay, so this is 12 volts minus 8.92. This is equal 3.08 volts. Okay, so this is the voltage across the resistors. Okay, the problem is asking me for V4, right? So my voltage across resistor R4 is equal to 3.08 volts. So next we're supposed to find I3. Okay, we're supposed to find I3. So in order to find I3, I'm going to simply use Ohm's law. I3 is equal V3 over R3. V3 equals 3.08 volts over R3, which is equal 6 kilo ohms. This is equal 3.08 divided by 6 exponent 3 equals 513.33 microamps. 513.33 microamps. This is my current I3. So we found I total, I3, we found V4, we found V6, so now we can find P1. P1 is the power at resistor 1. So P1 is equal, because I have voltage across resistor R1, so I can use the formula V1 to the second power over R1. V1 to the second power, okay, so V1 we said is equal 3.08 volts over here to the second power over R1, which is equal 4 kilo ohms. This is equal 3.08 to the second power divided by 4 exponent 3. This is equal 2.37 milliwatts. 2.37 milliwatts. And this is power at resistor R1. Next I'm supposed to find the power at resistor 6, so have P6 is equal, we found the voltage across resistor 6, that's why I'm going to use this voltage, so this is V6 to the second power over R6. So V6 we have 8.92 volts, 8.92 volts to the second power over R6, and R6 is equal 3.2 kiloohms. 0.2 kiloohms, and this is equal 8.92 to the second power divided by 3.2 exponent 3 equals 24.86 milliwatts. 24.86 milliwatts. Okay, so this is the power at resistor R6. Next, we're supposed to find the total power. P total is equal voltage source times I total. Voltage source is equal 12 volts times I total, which is equal 2.79 milliamps. This is equal 12 times 2.79 exponent 3 negative equals 33.48 milliwatts. We found all currents, we found all voltages, and we found all powers, so we can say that the problem is solved.